Hello, discrete math fans. In this section, we're going to talk about one-to-one and onto functions and how to create inverse functions and when they exist. Now, when we define a function, it's fine for several elements of the domain to map to the same element of the codomain. So when we think about an arrow diagram, that means two or more arrows that start in the domain at different points can point to the same element of the codomain. That's perfectly fine. Now, if it happens that no two arrows that start in the domain point to the same element in the codomain, then we're going to call the function one-to-one or injective, or we'll say that the function is an injection. For a one-to-one function, each element of the codomain is the image of at most one element of the domain. All right, so here's the definition, the formal definition of what it means for a function to be one-to-one or injective. So f is a function from x to y. We say that f is one-to-one if and only if for all elements a and b in the set x. If f of a is equal to f of b, then a is equal to b. Or we can write it with the contrapositive. If a is not equal to b, then f of a is not equal to f of b. If we want to write this in symbols with quantifiers, we'll say that f mapping from x to y is one-to-one if and only if for all a and b in the set x, the domain, if f of a is equal to f of b, then a is equal to b. Now, in order to understand what it means for a function to be one-to-one, maybe it's easier to understand what it means for a function to not be one-to-one. If we negate the last statement in the definition, we would get there exists a and b in the set x such that f of a is equal to f of b and a is not equal to b. And that is saying that there are two elements in the domain that map to the same point in the codomain. All right, in terms of the picture, here's what it would look like. If you have a one-to-one function, then two different elements in the domain get mapped to two different elements in the codomain. It's for this reason that maybe we should be calling one-to-one functions two-to-two functions. Two different elements in the domain get mapped to two different elements in the codomain. Whereas if you have a function which is not one-to-one, then it's possible that you could have 2 points in the domain that get mapped to the same point in the codomain. Okay, that's all for now.